In the last lecture, we discussed different types of equivalent circuit which are used for simulation of the transformer for different types of application. Today, we will try to understand another important aspects of a transformer. Rather, it is the most important characteristics of any electrical machine, that is the efficiency of the transformer. Efficiency of the transformer. So, everybody knows what is efficiency. Efficiency is output by input power. Output power by input power. That is the efficiency. Transformer transfers power from primary side to the secondary side. That means from the supply side to the load side. So, what is the efficiency of the transformer? While starting or trying to define the transformer, we told that transformer power will remain constant. Then you will say that when power remain constant, input power and output power should remain same. So, efficiency will be 1. That means 100% efficiency if you multiply it by 100. But actually speaking, that is the ideal condition. There we consider transformer not having any resistance. Transformer is not having any types of, that means while magnetizing the whole core, no current is required. That means permeability of the core is infinity. If it is infinitely large permeability, then very less or negligible current or no current will be required to magnetize it. But actually speaking, this is not the case. What happens? Transformer is nothing but two coils will be there, one primary coil, another secondary coil. That means two windings will be there. So, you know every winding is having resistance. Transformer is having inductance, leakage reactance is there. So, but leakage reactance, any types of inductive element does not consume any power. Only one element consumes power, that is resistance. And it is inescapable that you can make any type of coil, that means primary windings and secondary windings, without resistance. So, every coil will have resistance. Occasionally we tell resistance is negligible, but that negligibility is only when you consider the voltage drop across the resistance. But as soon as you consider the power losses, we will have to consider the resistance, whatever its value may be. So, for understanding the losses of transformer, we will have to consider the resistance of the two coils, whatever its value may be. The bigger the transformer, the smaller value it will be, but it will be the reason for the power loss of the transformer, because we know as soon as a current passes through a resistance, there will be I square R loss, or we call it copper loss of the transformer, because current generally flows through copper conductor. So, this was termed as copper loss, although nowadays we are using many other conductors like aluminums also. So, that is called copper loss. So, losses will be there. And we also know when a coil is getting magnetized, that flux will cause also some losses. So, here output power, if something is there, input will be more than the output. Input power will be output power plus losses. Output power, The input power will be output power plus losses, which we consider. So that this thing will be, that means input power will always be larger than the output power. So it depends on the design of the transformer, how less the loss can be. So that is our consideration. But before going into that, we should know what are the losses taking place in the transformer. So losses in the transformer. First major loss which occur, there are two major reasons for the losses of the transformer, that is power is getting lost inside the transformer itself. And it has to be kept in mind, that all the losses will be manifested in the form of heat. All losses, whatever may be the reasons, will causing the heat generation. That means your temperature of the transformer will rise. That means it will be another challenge for the design, that how this heat can be dissipated faster, so that the actual working temperature of the transformer does not go beyond the normal range. So what are the losses? First loss is your core loss. Core loss means your magnetic core, which is made of steel material, that is mostly silicon steel for transformer. For special types of transformer, there are many different types of alloys are there to increase the permeability, but that is used only in different type of CT, PT, which is highly accurate things there. But normal for your transmission power transformer, distribution transformer, which are used for transmission distribution purpose, and transformer which are used in different plants, steel core is used, that is silicon steel core. So their core losses will be there, which is caused by the magnetic flux. Then there will be a copper loss. Copper loss, which is the actual reason I told, when current will be passing through the conductor, because of its resistance, there will be I square R loss, and that loss will be called copper loss, and that is quite high. That is a major contributor of the losses to the transformer. These two are the main players which are causing losses in the transformer. Other than this, there is some stray losses may be there. This stray losses, say I told you that mutual flux takes part in the induction of voltage, but leakage flux doesn't. Leakage flux, actually it is not inducing voltage in the secondary, fine, but when it is coming in contact with our copper conductor, say, it will induce voltage there and causing some eddy current losses. Similarly, this leakage flux may induce voltage at the tank. The transformer actually in the core, two windings are there, cores are there, and this whole thing, that means core and windings, are encased in a tank, which may be filled with oil or which may be air, as a medium for taking out, transporting heat from the coil and core to outside. So this leakage flux may induce EMF at the tank itself, causing some current to flow and introducing the stray losses. And the stray losses can be caused by some harmonic fluxes also, especially triplet flux. So these stray losses are also a reason of loss, but its value is very small. Then next thing will be dielectric loss. So dielectric loss is when some dielectric is there. Our transformer use lot of insulation, lot of insulators we use, insulation also used. All these insulation are getting subjected to some voltage variation. And you know, when some insulator is subject to some potential difference, there will be certain polarization inside the insulators, and that causes some losses. So that is called dielectric loss, that depends on the voltage at which you are operating. Generally, for very high voltage transformer, it is having some value, otherwise it is negligibly small for small transformer. So these are the 4 main reasons for losses occurring in the transformer. So in the next lecture, we will be discussing about all these losses in detail.